My name is Anmol Gairola and I am a student of Vit Chennai, registration number 19BCE1615, and this is my assignment for NandToTetris Digital Assignment 1. For making AND gate using NAND gates, we will need two NAND gates. The first one will take both the inputs A and B, and the output will be the resultant, which will be A NAND B. And in the next NAND gate, you will have to send the same signal to wires so that it gets converted to A and B, which will in result from the AND gate. In AND 16, what we have is two inputs of which take 16 bits each, and all those inputs are passed through AND gates, normal 2-bit AND gate with 1 bit from each of the inputs, and then the output is generated. In DMux, what we have is two inputs A and B and one select line, and when the select line is 0 we will get A, otherwise we will get B. So first we have to pass in the select line through NOT gate so that we can make one signal of not select line so that we can have both the values of select is equal to 0 and select is equal to 1 as well, and then correspondingly we will pass inside the AND gate, we will pass one signal as in signal and the other as not select, and the output will be then the corresponding output according to this table will be displayed in the result. In DMux 4-way, we have two select lines, and because of two select lines we have four combinations. For creating the circuit we will need three demux normal ones, in which for the first one you have to input the signal in the incoming signal with the first select line, and you will get two outputs. From the first one, which is A, you can get output as A or B, and from B you can get output as C or D, and with further diagram we'll need two more demuxes, and from the first one you get A and B, with the second one you will get C and D, and the second select line has to be used for both. For DMX8 Wave, we will need three select lines. And that because of it, we'll have 8 combinations. First, we will have to use DMX 4-way, and using it, we will out of one, because from one input line, we will create 4, and that will be AE, BF, CG, DH. EE will later on be used as one input of a normal demux, which will then take the third select line to create A or E, and similarly B will create BF, C will create CG, and D will create DH. In a multiplexer, there are three inputs, one A, B, and select line, and one output, which is out. First, we'll have to pass the select line through the NOT gate and create both select line and another not select. From the first AND gate, we will pass A as the first input and not select as the second input, and from it the output will be out A. And from the other AND gate, we will pass the first input as B, the second input as select line, and the output will be out B. And finally, we will be sending both of these outputs through an OR gate, and the output of the OR gate will be considered as the final output of the system of the MUX. For 16-bit multiplexer, we have two 16-bit inputs and one select line as input, and as output we have out with 16 bits. For the construction, we will need 16 normal multiplexers, and for each multiplexer we'll have to pass for the first input as the first bit of A and the second input as first bit of B, and the select line will pass through it, and one of them will be considered according to the select line. Output will be generated. It will be common for all the multiplexers, and the resultant will give the entire resultant from now to 0 to 615. We will get the final result of the 16-bit multiplexer. In 4-way 16-bit multiplexer, we have 4 16-bit numbers that will be considered as input, and one select line which will be 2-bit, and one 16-bit output. For we will need 3 16-bit multiplexer for this chip. The first multiplexer will take all the bits of A and C and will take the select line as the first select line will be taken, and the output of this multiplexer will be either A or C depending on the select line. The second multiplexer will take the first input as B, the second input as T, and the select line will be the first one, and according to the select line we have an output which can either be B or D. And then we'll need the third one which will have OAC, which will have like the first input will be the output of the first multiplexer, the second input will be the output of the second multiplexer, and the select line will be that we will take is the second one, and the output of this multiplexer will be considered as the overall output of the complete system. In 8-way 16-bit multiplexer, we have 8 inputs, all of which are 16-bit, or 3-bit select line, and one 16-bit output. We will need 2 multiplexer 4-way 16 and one multiplexer 16-bit. For the first 4-way 16 multiplexer, the first 4 inputs will be given, and select line will be given from 0 to 1, that is 2 select lines, and the output will be generated output is stored as O1. In the other 4-way 16 multiplexer, we give the other 4 inputs and the same 0 to 1 select lines, and the output will be stored in O2. And finally, we will take multiplexer 16-bit, and for the 2 inputs we will have O1 and O2, and the third select line will be used, and the generated output will be the final output that we wanted this chip to give us. Making NOT gate out of NAND gate is pretty simple. All we need to do is, in the two inputs that the NAND gate has, just insert the same input that we want to operate on, and the given output will be the inverse of it. In NOT 16, we have one input which is of 16 bits and one output which is again of 16 bits. What we have to do is pass each individual bit through a NOT gate, and it will correspondingly generate the output we desire. To make OR gates using NAND gate, we will need three NAND gates. For the first one, we will pass the same input twice so that we can perform the NOT function. And from the second one, we do the same with the second input. And then finally, using both the outputs of the first and the second NAND gate, you perform a NAND operation, and that will be considered as the output. For OR 8 what we have is one input of 8 bits and one output. So we will have to use 8 OR gates, in which we first input the 0th bit in both the inputs and calculate the output. For the second OR gate, we take the second bit of the input, and for the second input of the OR gate, we take the output of the previous one, and we keep on doing this until we reach the last OR gate, and then we calculate the output. That will be our final output. In 16-bit OR gate, we have two inputs, both of which are 16-bit, and one output which again is of 16-bit. We have, for all the 16 bits, we have OR gates, and each bit is passed of both the input individually and is saved in the corresponding output bit. For making XOR gate using NAND gate, the chip takes two input and one gives out one output. First, we will need two NOT gates. From the first NOT gate, we will input A, the first input, and bring out the output and save it as NOT A. From the second NOT gate, we will take the input B and store the output as NOT B. Then we will need two AND gates. First, in the first AND gate, we will use the first input as A and the second input as NOT B, and save the output as O1. And from the second AND gate, we will take the first input as NOT A and the second input as B, and store the output as O2. And then we will pass both of the outputs of both the AND gates through an OR gate, and the resultant output will be the final output of the XOR gate. For making the half-adder chip, we will need two inputs, which are A and B, and two outputs sum and carry. First, we will need the XOR chip and pass A and B as the input, and the output of this XOR gate will be equal to the sum of half-adder. And the other gate that we will need is AND gate, and for inputs we will need A and B, and the output of generated from this chip will be the carry of the half-adder chip.